So thank you for having me. I am going to talk a little bit about myself and then what Cisco actually does in the LoRaWAN space. And as I'm the US government engineer for IoT, some of the challenges we have around data security for LoRaWAN. And then I'm going to talk a little bit about US military aviation and how we're using LoRaWAN to actually keep airplanes flying. Now, that doesn't sound um, particularly logical, and it might not even be interesting to you, but that's what this presentation is about. So, first of all, some of you may not know that Cisco Systems is even in the LoRa space. I borrowed this data from Clay, another Cisco employee who's down here in the front. Um, but today we've got over 480 customers with running LoRa with a combination of our gateways and our routers and our software around the world. There's Patrick, good to see another Cisco employee here. So we are a LoRaWAN player, and I just wanted to talk a little bit about the products that we do make here. And so in this space, we have our cloud-based product, which is marketed under the name Industrial Asset Vision. And that is an all-in-one LoRaWAN solution with Cisco-labeled sensors. Cisco made gateways and a cloud-based combination network server and application server. So the advantage of Industrial Asset Vision is that it's super easy to buy and it's super easy to use. What our customers do is they scan a QR code on a sensor and it automatically provisions that sensor and even the gateway in our cloud, single URL that you log into, and you can get your data from that all-in-one solution. So Industrial Asset Vision, Clay is one of the product managers for that, has been out for a number of years and is really kind of one of our flagship products in the LoRaWAN space. I'd like to point out that we've got that gateway there, the gray gateway called the IXM, which is another Cisco LoRaWAN product, an outdoor milled aluminum product that we use for most of our LoRa deployments. We call that lovingly the George Foreman grill. You're probably American if you get that joke, but it looks like a grill to make your sandwiches. The other products that we deploy that mostly I deploy for really large enterprise deployments and certainly for government deployments is this architecture. So we use that same George Foreman grill, the sandwich maker, the IXM gateway there on the left, with any one of the hundreds and hundreds of non-Cisco sensors out in the market. And then we deploy, with the help of our partners, Actility and WMW, we deploy network servers. So Cisco resells the Actility ThingPark solution set. And we also resell the WMW cloud and customer premise application server. So there are essentially two kind of network topologies that are here for our customers. One is an all-in-one cloud-based Cisco solution, and the other one is a very flexible customer premise ThingPark WMW Cisco LoRaWAN solution. So here's why I deploy the second solution a lot is in the United States, if you're deploying a cloud-based solution for the government, you actually have to certify that your data is going to stay within the United States. And that's the easy part. There's 1,000 other things that you have to certify to make sure that sensitive government data isn't lost on the public internet. It's funny, I don't work or live in Europe, but apparently in Europe, there are a lot of other countries that have data sovereignty regulations. I'm guessing, I imagine in France, that you probably require that the French government data stay within France as well. So it's similar in the United States. But then when you start to look at more sensitive government information, then there are higher classification levels, and they actually want to own the network that this runs on. So when moving into the LoRaWAN space, probably 4 or 5 years ago, I had a big problem where most of the cloud-based solutions would never be certified to work on US government networks. So instead, what we're doing for most of our US military customers today is we're actually taking the ThingPark enterprise and putting it in a Docker container. And then we take the WMW application server, we move it into a second Docker container. And we take those containers and we push it into a Pentagon private cloud. There's a bunch of them. There's a Pentagon private cloud run by Amazon called GovCloud. There's a Microsoft cloud, Azure cloud, run inside the Pentagon by Microsoft employees that's rated up to top secret. What we do is we take those containers and we push them into their cloud, and there you go. The whole thing has data sovereignty and is certified for use up to top secret. No work on my part. I pressed the button, moved the Docker container, and I fulfilled all the government requirements with Actility and with WMW. So to recap, we have a nice little LoRaWAN business at Cisco now. We've got global deployments with, for example, civilian agencies like the State Department. We have a forthcoming white paper about the State Department deployment. And we've got deployments with the Army, the Navy, and the Air Force, tracking all kinds of things: tanks, trucks, Marines who are running around. They lose Marines in the dark. You don't want to lose a Marine, so put little sensors on them to find the Marines in the dark. See Rob Hankerson laughing out there at this. So what I wanted to do in my remaining few minutes before I introduce Olivier, who I hope is here. There he is. Okay. I feel better about this whole presentation now. So what I want to do in my remaining few minutes before I bring Olivier up and kind of give the remainder of the hour to him is I'd like to talk a little bit about US military aviation. So because we have non-disclosure agreements with our customers, I don't want to talk about an individual customer. So what I've done is I've commingled all the data together to one giant customer that doesn't really exist. Let's talk about US military aviation. Click. There it is. All right. So I wrote down in my notes here some of the things I've learned in the last few years about jet fighters. So the US military likes to get 80% of the jets ready to fly at any given time. So the number they're aiming for is 80%. So do you think they hit the 80% number? They haven't hit that number for any individual jet for the last 9 years. Not even close. So I just started reading this on the internet years ago. For example, there's the F-22 fighter, and in the United States Air Force, there are 186 F-22s. As best I can figure out this month, only 93 of those 186 fighters actually can fly today. That's a disturbing number, but there's a reason for that. The F-22 is old and it's being decommissioned, and they're replacing it largely with the F-35 fighter, which is used around the world. And that fighter, the F-35 fighter, costs on average, depending on which model, you want to buy the nice one, not the cheap one, but the F-35 costs about $120 million per fighter. But that's the new airplane. So you think that their readiness number is better. So right now, the readiness number for the F-35 across the entire military is 61%, which I'd like to remind you is also not 80%. And then if you look at the pilots, the pilots are supposed to get a certain amount of practice flying their airplanes every month. And the goal is across the military that they should have above 16 hours a month of actual practice so they don't forget how to fly the airplane. So the goal is 16. You're trying to get over that, but all the planes are broken. So they're not hitting that 16-hour number. That number is 10.2 hours per month of actual practice. So to recap, the planes are broken and the pilots aren't getting a lot of practice flying the planes, which is, kind of bad, but the situation gets much, much worse. So far this year, 9 aircraft in the United States Navy have crashed. They crashed 3 aircraft in 1 week in June. There were 6 deaths in 1 week in 3 crashes. Now, there might have been other contributing factors like weather or maybe pilot error to this. But as someone who was never in the military and certainly would never fly an airplane, at first glance, these things seem to be somewhat connected. That most of the planes are broken. Most of the pilots don't have time flying the airplane. So we spend a lot of time going around air bases, and here are some pictures that me and my colleague, Randy Ben, we traveled together. We took with our iPhones at a US military flight line. So here you see on the far left in the upper left-hand corner, that's the nitrogen tank that you use to put the gas into the tires. They don't get air in the tires, put nitrogen. On the far right of this thing, you see something called a FOD sweeper, and that's a vacuum cleaner. Just like the vacuum in your house, the Hoover, I guess you call it in Europe, this hoovers up the entire runway so that you don't get little bits of metal stuck in the engine. In the lower left-hand corner, that's the electric cart, and you see a Cisco labeled LoRa sensor right on the electric cart. And then in the lower right-hand side, you see that's the jet fuel truck. So I'm just going to walk you through a couple of minutes, and I'll turn it over to Olivier. I'm going to walk you through 2 of the problems that contribute to readiness issues. So remember, to recap, 80% of planes are supposed to be flying. 50% of the F-22s, 61% of the F-35s. Here's problem number 1. You know what? There's another group, the United States Marines. They own airplanes. They're on the same base with the Navy. There might be Air Force people down the road. Let's say the Marines lose their nitrogen cart. Do you know what they do? They walk over to the Navy base and they steal the nitrogen cart from the Navy. And then they pull it on the back of a Jeep because they can't find their nitrogen cart. They pull it to their base in the middle of the night. And the first thing they do is they paint the whole thing Marine Corps colors. And then the Navy wakes up and they can't find their nitrogen cart. So the first thing they do is they go over to the Marine Corps base and they literally have fights over the nitrogen cart. So then the admiral gets involved and says, no one can leave the base on Friday night until we find all the nitrogen carts from the Navy and the Marines. And then everybody's upset because they can't go to the bar on Friday night. So this becomes a morale issue. So that's the first interesting story. Then the second interesting story, and again, these are our iPhone pictures, I'm not making this up. So let me tell you how they figure out how much fuel is in, jet fuel is in the truck. So you got this giant truck that may or may not be filled with jet fuel. Suddenly they have to send all of the airplanes flying out at a moment's notice. So they need to find out if the truck is full of fuel. I love this. The process is an 18-year-old boy climbs up on the top of the truck with a stick, and he puts the stick into the truck and measures how much fuel is on the stick. He gets back in the truck and does some calculations to figure out the number of liters of jet fuel in the truck. is if you're old like me and were alive in the 1980s, you might remember how we paid by credit card in 1985 for gasoline. You would take your plastic credit card and you would put it on a machine with carbon paper, and you would run the credit card machine over the carbon paper. If you've seen Top Gun, there's no credit card machine, but that's how they actually keep track of how many liters of fuel are put into each Navy wing's jet. So anyway, we're not solving the entire problem here. I'm right at the end of my time, my 20 minutes. And what we've done is we kind of faked this a little bit. We're taking all this data from the nitrogen card, from the jet fuel, from meters measuring the flow coming out of this, to count the number of liters of fuel. We're putting sensors on people who are right now signing in and signing out of their location. We run all of that through ThingPark Enterprise in a Docker container, in a Pentagon, in this case, AWS server. And then we visualize that in WMW on the applications of the desktop for the people that are managing the wing. So the only pictures I had of that were the actual fuel trucks at actual bases. So this is Node-RED, not WMW, which we sometimes use for quick demos, but we actually visualize this, give the right data to the right people using WMW, but it's all customer premise. So we don't have to answer any questions about, well, wait a minute, who else are you telling about where my fuel trucks are? Is this sensitive information? Yes, absolutely, it's sensitive information. So I just want to give you an idea in my 20 minutes of how we're using LoRaWAN in very concrete examples for very important mission-related functions. I'm not saying that we're solving the readiness problem in US military aviation. All I'm saying is we're not hurting the readiness problem, and this kid with a stick is probably not helping the situation, right? So we're slowly digitizing all of these processes: doors, trucks, people, safety, finding Marines in the middle of the night. We're digitizing the process in a secure, customer premise, virtualized manner, throwing all the data into a Docker container and doing it cheaply and really efficiently. So again, my name is Mike. I'm with Cisco. If you'd like to talk about this any more, I'm very passionate about this topic. And on that note, I would like to introduce Olivier. So, thank you.